Okay, this is the second part of our presentation on a continuous random variable question. So essentially what I'm going to do here is we're going to pick up a part C. So we have part C, part D, and part E. But actually just go back to the start here. And just to remark upon that what we have done here is that we have evaluated, essentially what we have to do is essentially work with this function here, or this PDF. This is the PDF of the function we were working with. It has a range of, it is active in the range of values between 0 and 1, okay, and elsewhere, previously we found out that k was equal to 30. So essentially what we had to do is evaluate k there. So it's 30 times x squared times 1 minus x to be squared, okay, which is also something we have simplified. And I'll just sort of go straight to that simplification later on, okay. So that's the last video there. So in this one, what we're going to do is pick it up here. So probability of x being less than or equal to 1/3, show that it is equal to 17 over 81. So essentially what we have to do here is we're going to calculate the CDF, okay? And remember that the range of values is essentially between 0 and 1 for the entire range of values for x, okay? So what we want to do there is see what proportion falls between 0 and 1/3, okay? So what we're going to do is evaluate that. Now, so essentially what we're going to do here is, yeah, there it is. So essentially it's another definite integral, okay? So in this particular question, just following on from what we've done previously, so in this particular question, rather than integrating from 0 to 1, what we're going to do there is integrate from 0 to 1/3. This is the PDF, the probability density function. So essentially what we have to do is integrate that. So what I'm going to do there is simplify it. I'm also going to take 30 out. Okay, just put it out there out front just to make it easier to read. So when we have x squared times 1 minus x to be squared, that simplifies as x squared minus 2x cubed plus x to the power of 4. Integrate that. Use the limits of integration as 0 and 1/3, or okay, or 1/3 and 0, as I have it there. So integrating it out, we have, what have I done there? I just sort of simplified that. Rather, not much work there, not much progression there. So essentially what I've done there is when we integrate it, we get x over 3 over 3, x to the power of 3 over 3, minus x to the power of 4 over 2, plus x to the power of 5 over 5, and we integrate that between 0 and 1/3. So just working it out there, there we go. We just substitute in the value of 1/3 and 0 where x is, and subtract 1 from the other. Okay, so in the case where we have 0, you don't really have to do it. Or just check that you don't need it. And in this case, particularly if you're new to all this definite integral stuff, just check that it evaluates all in each time as 0, because that's not always the case. Okay, so 1 over 3 to the power of 3 divided by 3 minus 1 over 3 to the power of 4 divided by 2 plus 1/3 1 over 3 to the power of 5 over 5. Okay, now this turns into a good bit of number crunching here. Okay, so essentially, just as a quick remark, that yeah, it actually can these numbers can get quite clunky very quickly. Okay, so what we have here is yeah, so essentially what I have here is I've done it in a sort of way that makes it a little bit easier to read. So 1 over 3 to the power of 3 divided by 3, that simply comes 1 over 3 to the power of 4, which is 1 over 81, which is what we're looking for. 1/2, okay, I just re-expressed that as 15 over 30, and we have 1 over 3 to the power of 4 there as well, just like this first term, okay, so that's starting to take shape, okay. So 1 over 5 can be rewritten as 6 over 30. Now, you notice previously we have 1 over 3 to the power of 4 and 1 over 3 to the power of 4. If we work that out, we would know that to be 1 over 81. So that's sort of dovetails with what we are expecting. Okay, so let's try and use that. So we have 1 over 3 to the power of 5 there. Let's sort of split that up into 1/3 and 1 over 3 to the power of 4. And then what we can do is combine that 1/3 and that 6 over 30. Let's combine them into 2 over 30 there, okay? Now, we have, just going back here, essentially what I'm going to do there is just express, that's 1 times 1 over 3 to the power of 4. So we just can express that as 30 over 30 without any loss of generality there, okay? So we have this 30 here, that's kept out there. In each case now we have 1 over 3 to the power of 4. So we'll bring that out here, and then what we're left with is those coefficients there. Okay, 1, which is 30 over 30. The other 2 is expressed in terms of a 30th. Okay, so when we work that out, that expression there, that would work out to be 17 over 30. Okay, so that part there, that's 17 over 30. And so essentially when we combine everything back together, we get 30 over 81 times 17 over 30, which gives us the answer we're looking for, which is 17 over 81. That's perfect. Okay, so these, you're sort of given a bit of a guidance there at the start as to what to do. 17 over 81, so it should work out. Okay, it takes a little time, a little patience, a little bit of care with dealing with all these numbers. Things can get tricky. Okay. Now, a random sample of size 5 is taken from this distribution. Find correct 4 decimal places the probability that all 5 observations exceed 1/3. Okay, so the probability of exceeding 1/3 is, I just make a note to myself that font should be a little bit larger, but I hope you can read it there. So the probability that an observation exceeds 1/3 is the complement of what we just found here. Okay. So it can be written there as probability of x greater than or equal to 1/3, which is the complement of that, and that is 64 over 81, which is 1 minus 17 over 81. Okay, so it's 64 over 81. So these are 5 independent events. Essentially what we do is just multiply that, or get that value to the power of 5, and we work that out, and it comes out to be 0.3079 or 0.31 if you want to round it to 2 decimal places. Okay, so yeah, that's the second part there. Okay, so that's really independent events. That's what you're looking at there, independent events or repeated trials, repeated independent trials. Okay. So the last part is correct the 4 decimal places, find the variance of the mean of the random sample of size 5. So this is essentially what we do there is get the variance of the x and divide it by the sample size. Okay, this is actually related to stuff called standard errors that you might sort of see in hypothesis testing later on. Okay, so that's all. Essentially, for a sampling distribution, which is what we're dealing with here, sampling distribution, the probability essentially just divide by the sample size. So this is the variable there, and this is the sample size. Okay, and so the variance is 1 over 28. That's something we found in the first part of this video here. This value was deduced in part B. This is part E. Sample size is 5, so 1 over 28 divided by 5, that's 1 over 140, and that is our value there. Okay, so that's it. We'll leave it there. You're coming up on 10 minutes, 9 minutes. Okay,